Well, hello and welcome back to another exciting topic in our flipped classroom. Today's topic is called factor by grouping. Now, this is a brand new method to us, something you've never seen before. And we're going to use this method, and we can jot this down in our notebook here. We're going to use this method when we have to factor polynomials with 4 terms, and that's the key. Let's highlight that word, 4 terms. Now, we don't necessarily have a special name for these polynomials with 4 terms. Monomials would be 1 term. Binomials would be 2 terms. Trinomials are 3 terms. But anything after that kind of just gets lumped into this group of polynomials, functions with many terms. So perhaps one of you guys out there will be famous enough and will be able to name this crazy polynomial with 4 terms. So before we get started today, I just wanted you to jot down in your notebook that the whole key concept is all about pulling out a GCF. Alright, so if you are good at pulling out GCFs, you are going to love factor by grouping. Now, before we actually do some factor by groupings, let's just slow down and practice a few GCFs just to get in the groove. Alright, so example 1 here. Again, my goal is just to pull out the GCF, the greatest common factor. So you'll notice I'm going to compare each of these terms, and I'm looking for not only a number, but a variable to pull out as well. So, I'm just saying divisible. What number is divisible by both 8 and 12? What number goes into both? Well, hopefully you guessed it. I'm thinking 4, and I hope you are too. And now I need to pull out x to some power. Can you think about what goes into both of those? I'm going to say x to the 3rd. Now, if you're confused on where that came from or you're not 100% sure, maybe let's just make a note in our book here. You can always pull out the smallest exponent. Alright, that little trick will work every time. Just pull out the smallest exponent. So out of the x to the 4th and the x to the 3rd, I'm pulling out the x to the 3rd. And then basically I just need to write what is left. Now I just want to be clear, you will always have something minus something. There has to be 2 terms. If you start with 2 terms, you have to end up with 2 terms. So in theory what I'm doing is I'm really just dividing these terms both by 4x cubed. Okay, by 4x cubed. So I would say 8 divided by 4 is 2. And x to the 4th divided by x cubed, well, we just talked about exponents last week. When you're dividing, what do you do with the exponents? Yep, you've got it. You subtract, so I get 2x to the 1st. Minus 12 divided by 4 is 3. And anybody on the top and bottom that are the same just cancel out. So this would be my final answer here. And again, how do you know if you're right? Well, you take 2 seconds and you distribute back and you see if you get what you started with. And of course, I get the same thing, so we know we're correct there. Let's try one more example before we get into our grouping. We've got 6x cubed minus 4x squared plus 10x. So again, I'm looking for that GCF. I'm looking to see, start with the number. What number goes into all 3 of those? It's got to be the same number. And hopefully you've guessed it, a nice 2. Now remember, you can pull out the smallest exponent. So I have a 3, a 2, and a 1, of course. So I can pull out a 2x. And then I have to write what's left. Now again, you'll notice I have 1, 2, 3 terms. I have to end up with 3 terms here. So remember, I'm just dividing out. If you ever get stuck, just divide each one by that 2x, and we're just going to write what's left. So I would say 3x squared minus 2x plus 5. Now again, take 2 seconds, see if you're right, just distribute it back through, and see if you get what you started with. Alright, so we've mastered our GCFs, and we are ready to attack factor by grouping. So the directions are going to say one of 2 things. So we'll start with this first set. Factor completely. So we just have to make sure we're factored completely in the end. Now, like I promised you, factor by grouping is special because you will have 4 terms. And, the first thing I would do is look for a GCF, but do all 4 terms have something in common? You might be thinking x, but does this bear have an x on the end? No. So they don't have a GCF of x. So here's what we do to factor by grouping. What I want you to do, we're going to use brackets, and you don't have to be amazing at drawing brackets, just do your best. I want you to bracket the first 2 terms together and the next 2 terms together. And you're just going to factor a GCF out of the first 2 terms and the second 2 terms. So again, just looking at these first 2 terms, what GCF could you pull out of them? Hopefully you've guessed x squared. And now just write what you get left when you pull out an x squared. Well, x cubed divided by x squared is x. 7 minus x squared divided by x squared is 7. Again, take 2 seconds, distribute it back through to make sure you get what you started with. Now, we've got to factor this next pair also, and that's why we put the brackets around those two. Now, here's the trick, guys. You could either pull out a positive 4 or a negative 4. Let's say we pull out a positive 4. All right, and you have to put a plus sign if you pull out a positive 4. If I pull out a positive 4, I'm left with a negative x and a plus 7. All right, now here's the deal, guys. These two terms, underline them right here and here, they have to be the same. Are those the exact same? No. So what I want you to do is I want you to scratch this out, and instead of pulling out a positive 4, let's pull out a negative 4. Now divide both terms by a negative 4. Well, negative 4x divided by negative 4 is x, and positive 28 divided by negative 4 is negative 7. Now, are those two terms the exact same? All right, and I hope you're saying yes. So the first little mark I want you to put in your notebook there, let's put a little star. All right, and let's say we have to have the same, and those are, remember, those are two terms, so let's say same binomial. All right, we have to have the same binomial. Now at this point we're halfway done. All we did was, we factored out a GCF and we're halfway done. Now we're going to do it again. I want you to bracket these two terms in, okay, that term. I want you to bracket that term. And we need to look for a GCF, and let's put another little star here. We are looking for a GCF that is a binomial. A GCF that's a binomial. So again, I'm looking for a GCF that has two terms. So I have this and I have this. Do you notice anything like we said that's the exact same? Well, this x minus 7 is. So we're going to factor out the x minus 7. And in a nice bracket, I want you to write what's left. If you take the x minus 7 out, you're left with just x squared. And if you take the x minus 7 out over here, you're left with a negative 4. We've got that in a nice bracket. All right, now, I'm almost done. I just have to make sure I'm factored completely. X minus 7 cannot get factored anymore. But this guy can. How does x squared minus 4 factor? I would say x plus 2 and x minus 2. Now we are factored completely, and I want you to put a little FC there. Factored completely. None of these can get factored anymore. And that is our first problem of factor by grouping. Now, if you didn't quite get it the first time, we're going to do quite a few examples. So stick with me and let's just make sure we get every example down. Alright, so I think we're ready to tackle our second problem of factor by grouping. Now let me just refresh your mind. Why is it called factor by grouping? Well, remember, grouping means you have 1, 2, 3, 4 terms without a GCF. So again, the directions say factor completely, and that's what we'll do. So just take that pencil and let's bracket the first two in, because we don't have a GCF of all 4, and bracket the second two in. Alright, just staring at the first two, what is your GCF? Well, number-wise, I would say the number 3, and also x squared. And then we'll put a nice parenthesis. Now if I take 3x cubed and divide by 3x squared, I think I'm left with just x. And if I take 6x squared and divide by 3x squared, I'm left with a minus 2. Now again, how do you know if you're right? We'll take that, distribute it back, see if that's what you started with. Alright, next pair. I need a number that goes into 27 and 54. Now if you ever get stuck, remember, you want these to be the same, right? They have to be the same. So I basically say to myself, how many times does 2 go into 54? And that goes in 27 times. Now, the key is, do you want a positive 27 or a negative 27? You have to have a sign here, whether you put a plus or a minus. Which one would be smarter to pull out? Well, hopefully you said a negative 27. Now carefully divide both by negative 27. So negative 27x divided by negative 27 is just positive x. And positive 54 divided by negative 27 is negative 2. Alright, did the magic happen? Is your binomial the same as this binomial? Alright, that's our first check. So again, I want to make sure my binomials are the same. Alright, now we do another GCF. Take that pencil. We want to bracket this first term in and the second term. we're going to pull out the binomial GCF. So let's write that down again. Pull out the GCF binomial. All right, so I'm going to take out the x minus 2 from both. All right, I'm going to put a nice big bracket here. When I take the x minus 2 out, and feel free to scratch it out with your pencil, what's left? Well, I think you can clearly see the 3x squared. Then you have a minus sign. When you take out the x minus 2 here, you're left with the number 27. All right, now I want to make a little note. We got a little bear trap here. All right, are we factored completely? And that's the key. Don't fall for that on a multiple choice question. I don't think we're factored completely because I think we can keep factoring inside that bracket. Now I can't do anything to the x minus 2. All right, but what type of factoring could I do here again? I could pull out the number 3. And when I do that, I'm left with x squared minus 9. Now, are you factored completely? Well, no. There's another bear trap in there. This guy can get factored again. So we just keep factoring. So I've got x minus 2. I've got the solid number 3. And this can factor to x plus 3 and x minus 3. All right, now take a look. Are you factored completely? Can anybody get factored again? No. So now we can put our stamp of approval on there. We can put a nice little FC, box it in, do what you need to do. We are factored completely. And again, that's our factor by grouping. All right, let's get ready for that third problem. So notice the directions this time. It says solve. Now, we all know we've solved equations before. Solve makes you go one more step, and solve is when we tee it up. All right, when we actually solve and we get answers for x. Now, let's go into this problem with some expectations. This is called a third degree polynomial. Let's jot that down. Third degree polynomial. Can you guess why it's called a third degree? It's not super mind-blowing, but it's called a third degree because our highest exponent happens to be the number 3. Now, what does that tell you? Well, you can expect 3 different roots or 3 solutions when that is a third degree polynomial. If my highest exponent was a squared, like a quadratic, x squared minus 3x, I could expect 2 roots. All right, so I know I've got 4 terms with no GCF, so let's factor by grouping. Why don't you pause it and see if you can pull out the first 2 GCFs? Now remember, the more you practice on your own, the easier this will be. So pause it and see what you get. All right, I'm not going to pull out a number, but I am going to pull out an x squared in this term. So I am left with 4x minus 5. Now, in this section, I need to have a 4x minus 5, so I think they're both divisible by 3. Now, the question is, do I want to pull out a positive 3 and put a plus 3 here, or a negative 3 and put a minus 3 there? Well, hopefully you said a negative 3, because when I divide a negative by a negative, I should get a positive 4x minus 5. All right? And how do you know you're on the right track? Did these 2 terms match? All right, if they match, you know you're in the right direction. Now, let's get those brackets on one more time. And we're going to pull out the GCF of the binomial. Okay, so this bracket and this bracket have a GCF of 4x minus 5. Remember, make a note if you need to. We're pulling out the binomial GCF. Now let's bracket in what we have left. Take out the 4x minus 5. And here you're left with x squared. Then you're left with the minus sign. And if you take it out here, you're left with a 3. All right. Now, you'll notice this one even had the equal 0 all the way because we have to solve now. So you're literally just going to tee it up in between those 2 factors and carefully set each side equal to 0. All right, now they're not pretty answers, but that's okay. I'm going to add my 5 over, so I get 4x equals 5 divided by 4, and x equals 5 divided by 4. Now in this one, I'm going to get the x squared by itself, so I'm going to say x squared equals positive 3. Now use some sense here. We're going to get rid of a square by taking the what of both sides. That square root. Now the most important part is don't forget what goes in front of every square root. Plus and minus. So I need to get x equals plus and minus radical 3. So now you can clearly see that we got 3 answers just like we predicted. We've got positive 5/4, negative radical 3, and positive radical 3. And again, we'd predicted we'd get 3 answers because that was a third degree polynomial. All right, well, we've got one more factor by grouping tonight. Notice again, it does say solve, so we are going to tee it up in the end. All right, and let's just take a GCF of our first 2 terms and a GCF of our second. So I'm assuming by this point you can pull that GCF. Why don't you pause it, pull out your GCF, and see if we get the same thing. I'm going to pull out an x squared. So I get 2x minus 5. Okay, now on this side, remember, just determine whether you're pulling out that positive or negative. I definitely think a 6 goes into both, and I want to pull out a positive 6. Now, I can't stress enough, all right, I want you to make sure you put a plus sign here. You have to put the sign in front, whether it's positive or negative. And I would get 2x minus 5 again. Now, is that key? Is that what's supposed to happen? Was this term and this term the same thing? Yeah, so we know we're on the right path. All right, now take that bracket in before the plus sign and after the plus sign, and let's pull out our GCF of the binomial. All right, remember the binomial is the 2 terms that are in common. So I can pull out the 2x minus 5. All right, so literally cross it off. We're taking it out. All right, and then we'll put a bracket, and what's left? On this bracket, I'm left with x squared. Then there's a plus sign. And then in this orange bracket, I'm left with the plus 6 equals 0. All right, now don't forget, let's tee it up. Set each side equal to 0. And x squared plus 6 equals 0. All right, let's solve for x. I'm going to add my 5 over and divide by 2, so I get x equals 5 halves. Now on this side, watch out, I get x squared equals negative 6. Now, before, we would be afraid of that. That would kind of spook us a little, but not anymore. When we take that square root, remember, we're still going to put our plus and minus. Let's just be smart. Because there is a negative number in there, remember, you're going to get a what type of answer? I'm going to get plus and minus I radical 6. Now, if I could break 6 down, I would, but my only options are 1 and 6 and 3 and 2, so I don't actually have anything to break down. So my solutions are 5 halves. I've got negative I radical 6 and positive I radical 6. Okay, now again, if I scroll back real quickly, I should get 3 solutions because again, I have that third degree polynomial. Well, that does it for us tonight. If you were totally lost, remember, pause, rewind, and go back, and we'll be around in the morning for any help. Have a great night, and we'll see you tomorrow.